Welcome to Three Devs and a Maybe. Now introducing your show hosts, Michael Budd, Fraser Hart, Lewis Keynes, and Ed Mann.
Hello and welcome to another episode of Three Devs and a Maybe. My name's Ed Mann, and today we're very lucky to be joined by Niall Murphy. How you doing, Niall?
Hey, how's it going?
It's very good, very good. And speaking off air, was it 14 meetings that you've had today, and now you've signed yourself up for a podcast, so plenty more talking.
Very much so. As a partially professional extrovert and also a partially professional pessimist, those two things can be combined in the S3 role. I find I have started going to a lot of meetings in the recent past. So,
well, yeah, we'll definitely have to talk about that. Would you mind for the audience giving a little introduction about yourself?
Sure. So I guess in terms of what got me into computers at the start, I really imprinted on kind of Tom Baker era Doctor Who in the 1970s. I guess that wave of sci-fi that came with Star Wars and Doctor Who and so on, I was definitely influenced by. From a very early age, I can remember my mother, I'm the child of a single mother. My mother would bring home the magazines of, the PC Worlds and the Tomorrow's Worlds and so on of the day, and I would leaf through them. We weren't actually able to afford any kind of computing technology apart from the wooden Atari 2600 until I was about 10, I think, and that was an Amstrad CPC 464, the very first computer I got. And I did all of that kind of typing in from listings thing that you do when you're a child of the 80s. And it was all good.
Very cool. And what? So did you then start off then in like a developer role when you left uni or kind of out of school?
No. The progress of my career was a little interesting in some ways. So the way it works in Ireland is you do a terminal exam, which is called the Leaving Certificate, and it's a very market-based system. It's very fair in some ways, very unfair in other ways. But the way in which it is fair is the number of marks you get in each of the 7 subjects that you do are totted up, and that mark is compared to the marks which are allocated to, or the threshold levels which are allocated to the subjects the courses advertised by the universities in general. And what the universities do is that if they have a lot of places in one particular course, the points for it go down so that they can allow more people to join. And if there are a small number of places, the points are usually high, etc. And then there's some market distortions where, everyone wants to be a doctor and a lawyer. And the particular year that I went into uni, I was going back and forth on whether I would do philosophy and English or computer science and mathematics. And I ended up picking computer science and mathematics. And when I was in university, I had a very strong practical orientation. I really wanted to be using the machine and getting it to do real things from very early on. But I later came to discover that the department that I went to at the time had a very strong theoretical orientation. And so the first year had a lot of formal derivation kind of stuff in it and not that much practical orientation. So I kind of fell out of love with the department, at least for a while. But I did start the University College Dublin Internet Society when I was there in the 90s. Which actually ended up giving internet service and a shell account, as was then, to, I think its height, about 2,000, 2,500, 3,000 students. We were essentially doing computing services job for them across a committee of system administrators and who were all students and one very big box. So my career started relatively early on in the sense that I was actually working in university as a computing person and not being paid for it for a while.
I was thinking for free.
Yeah. And then I was working as a computing person in university for a while and getting paid for it. And then I actually wrote a history of the Irish internet, which is at www.internethistory.ie, if I recall. But one of the first jobs that I actually had was a thing called a programmer hostmaster.
Ooh.
And a programmer hostmaster, as well as being a job title which no one in the world has heard of, is a way of mapping in a programmatic way, or as a software developer, one works on DNS and one is registering domain names for the root name service in Ireland, which at that time was co-located with the university and later split out. But I had I had a series of roles in internet infrastructure companies, often at the intersection of automation and system administration, or automation and network engineering, which is what I did in Amazon in the very early days when Amazon's Dublin office was opened. And then in about 2006, I joined Google, where I spent 11 years. And in the very recent past couple of months, I joined Microsoft as their Director of Cloud Engineering and Site Reliability Engineering.
That is a very, very nice, rich history for sure.
I don't regret a single minute of it, even though a lot of it has been extremely intense. And someday I suspect I'll need to get my adrenaline glands replaced, but very much enjoyed it.
No, absolutely. Very interesting. And I think you touched upon it a little bit earlier, actually. One of the reasons why having you on, is the fact that you helped co-author the SRE book. Personally, for me, SRE is a very new role, very interesting new role. And it's typically been, I can kind of look at it from a bird's eye view, and typically how, as a developer would see it, you've got developer ops friction. And there's always been this thing where, developers, we want innovation. We want new features. We want to be able to, release stuff when we want to see change. And ops want things to just, work. They don't want to because they'll be the ones that have to wake up, early morning, or they at least, have to try and change or fix these things, mitigate these things until a developer can actually get around to it. Or, what ends up happening is really the ops team ends up having to maintain this code years and years after the developers come along. So you get this kind of friction. Ops wants to keep things the same, dev wants to move things, and how do we kind of get around that? And there's this new role, this kind of new movement, essentially, is site reliability engineering. I was just wondering, maybe, would you mind explaining to the audience and to me, actually, what this role is, how it came to be, and really what the philosophy behind it is?
Yeah, so there's a couple lectures worth of material in this, and we could probably spend the next couple of days talking about it. But in general, I think the way I'll start is that I'll say operations is terrible, by which I mean we have been trying to operate things as a species for millennia. There's actually a piece in a paper I co-wrote with Liz Fong-Jones about the relationship between DevOps and SRE, which talks at the start about this. Like, we have, as a species, been trying to operate things well for ages. But in the IT realm, the act of trying to operate things effectively, particularly in the case where you have what I'll call a hard stack split. When you look at the stack ranging from the full stack, before that meant 4 kinds of JavaScript, when you talk about hardware all the way up to user-facing JavaScript, going through, device drivers, kernel, libc, middleware, other kind of cloud layers of stuff, and application layers, and then the, say, user-facing JavaScript, what you have in the development and operations world is a hard split somewhere around libc, where the system administrator knows about command level things to run typically, and is responsible for the health of a box, and is not really responsible for the success of the application on the box, or more accurately, is responsible for the success of the application on the box, but is not equipped to actually do anything about it. You have actively unaligned incentives. And that hard split in responsibility, in capability, in vocabulary, in parity of esteem, in everything, really means that as a kind of a holistic unit, that setup for actually delivering code to production is basically non-functional. So in the extreme, it ends up with teams unable to talk to each other, no respect for each other whatsoever, all kinds of finger pointing, nobody really saying or what's actually happening. No one has the holistic picture in mind, et cetera, et cetera. Now, there are a couple of possible responses to this, and the DevOps movement, which you have talked about previously, is one of them. And the SRE, I guess, movement doesn't really feel like quite the right word to me, but the SRE role, perhaps. One of the things that we've been working on recently is a illustration of how you might compare and contrast DevOps and SRE. And DevOps in this overall framework is a kind of philosophy, which is really business oriented. And it's talking about, okay, in your business, you have some technical underpinning to the business. That's certainly true. And we want to make that business move faster. And so we tend to find DevOps folks orienting around continuous delivery and continuous integration type systems. But it's really a much larger philosophy about how you should organize your business. Now, weirdly enough, DevOps folks, despite having ops in the title, the philosophy of DevOps is relatively unopinionated about how operations should be conducted. When you look at the SRE book, you don't see a lot of philosophy about how your business is or how breaking down silos is valuable. Yes, it's there. I mean, it's in some ways a basic assumption that the business is working on a useful level already, which often requires breaking down silos and effective communication and a bunch of other things. But the SRE body of practice is an opinionated body of practice about how operations should be conducted. And that is its main difference between SRE as a role and DevOps as a philosophy.
Interesting. And what drew you then to SRE? Like, when were you first introduced to it?
So again, my career in Google was a fairly fast-moving career. Day one, I turned up, and the person that had said I would report to on my contract, I was reporting to somebody else. Within 3 months, I had changed desk twice, teams twice, and location once. So as far as I'm concerned, I was introduced to SRE relatively early on. But ironically, my group didn't receive the same SRE training that a lot of the other SREs in Google did at that time. So we kind of had to make a lot of that stuff up for ourselves or learn a lot of that for ourselves. But I started off as a system administrator in the SysOps group in Google Dublin in November 2006. And by about spring 2007, we were in an SRE team that was looking after a variety of some of them internal applications, but actually a number of them also being externally facing applications. So we were doing the SRE thing from relatively early on. Google itself, of course, didn't invent the SRE thing then. It had started it a couple of years earlier. Part of the reason it had started an SRE group as opposed to organizing things with, for example, the development and operations split we were referencing earlier, is because there was a huge ideological reluctance inside Google to construct a job role which would be there primarily to follow playbooks. And the view very much was that if a playbook could be constructed and could be followed by a human being, there was a piece of software that should be written for it.
That is definitely the developer way, isn't it? You know, if I'm going to have to do this a couple of times, I need to write a script to, do it for me.
And I say ideological, and I say ideological because I mean that it is followed to the extreme, even when it is not of value, as well as those cases when it is value. For example, there would be many operations that Google folks would not be able to conduct in a programmatic way for various reasons, like maybe even there isn't just the time to write the software required to do it. And those operations would end up undone because there wouldn't be a piece of software you could write in time to do it. Other companies would hire a vendor or they would pay somebody to do it, but not in Google.
So what kept you with the role there? Because obviously, you said that you kind of flung around a little bit and then you kind of landed in the SRE role. The mix and the blend of all the different things that, come about from doing that role, was that the things that really kind of got you, that kept you hooked to it?
Well, some of it's partially Google and some of it's partially the role. Google, of course, planet-spanning systems, lots of tech running around. It's a place that's very hard to be bored in. You can get unlucky, and there are definitely people who have been dissatisfied by their Google experience, and that's totally fine. But for a large number of years, the technical challenges that I was dealing with, I was growing all the time. And this is the era, I guess, the 2006 to 2016 era had so much happening in it that Google ended up being centrally involved in. If you think about, yes, the search engine, yes, Gmail, yes, Android, the phenomenal growth of ads products, Google Plus, all of that kind of stuff. There's just a lot going on. And the role itself, as opposed to the company in which it happened to be conducted, the role itself is also a fascinating hybrid role, because not only do you essentially have to be better than either product developers or operations staff at the things that they both specialize in, you also develop a very interesting feeling for intuition, I should say, for architectures that will work and architectures that will maybe work less effectively. And you migrate, I guess, at one end of the spectrum towards being a systems architect, except to a certain extent, that's a dirty word in Google SRE, because seriously, architects in the outside world have a kind of a whiteboard style reputation. Like, you go into the office and you ask the architect how to do something, and the architect will draw up this diagram on the whiteboard, and you'll stare at it and you go, thank you very much. And then you'll try and implement it and you'll find out it won't work. And the difficulty there, and this is where it matches with my own personal preferences, is that SRE is a very strongly practical and pragmatic role. And if the thing doesn't work, like, I don't really care what the theory says.
So where is an SRE actually then positioned within a group then?
So it depends. And again, I do want to distinguish as carefully as possible between the implementation that Google happens to have done, which is obviously seminal and lots of documented material about, and so on and so forth, but also what other people do in reaction to the traditional developer operations split. Sometimes those things overlap, and sometimes they do that less so. For example, I know that in Facebook, they have a strong, maybe preference is the wrong word, but they do a lot of embedded SRE. They call it production engineering work, where a small number of people will come and sit with the developer team, help them to learn about production technologies. Maybe there's some particular launch they need help with over a kind of couple of quarters time frame. And basically the person becomes one of that team for the duration. And then they're rotated out and they do something else. Whereas in Google, the usual strong preference is for a team of SREs who are bound to a product, and sometimes a set of products, depending on various factors we'll get into. And that team versus embedded model, people are doing basically the same work, i.e. wrestling with the complexity of production in one way or another, but they can do it in different organizational contexts.
So I thought it'd be really interesting, actually, maybe to go into some of the ideas that kind of compose to become this SRE role. And one of the big ones is the concept of an SLA. Would you mind explaining to the audience what an SLA is?
Yeah, so SLA stands for Service Level Agreement. Actually, the slightly more fundamental concept underneath that is a Service Level Objective, which SLO, which itself relies on SLIs, which are Service Level Indicators. All of these are fancy ways of saying there's some number attached to some performance or attribute or etc. of the system, and we want that number to be at a particular threshold. Like, that's almost always what it ends up being like. An example is for a web-based, user-facing serving system of some kind, you generally want the system to respond within a reasonable length of time, and usually reasonable. You can actually get quite detailed assessments of the precise delay that a human being will interpret as a system being non-responsive and so on. So there is quite a lot of prior art on this. But basically, you have an SLA of, we want 99% of queries to be responded to within 50 ms or something like that. And that is some target that the system, that we've decided on a business level that the system should make. And that target, if we fall beneath it, we take actions to correct it. And if we're above it, we're all hunky-dory and that's fine. Now, this is a business decision, right? And so many business people listening to this would say, well, why shouldn't I pick a target of like 100%? Because like I want my thing to be up all the time.
The ideal world.
In the ideal world. And actually, there's loads of reasons why that isn't the right target. And some of them are quite subtle. The first reason is that if you look at the reliability of typical consumer equipment, and we will locate this response in the business context of typical consumer web services for the moment. But if you look at the reliability of those systems, you find out that actually more or less everything in somebody's house that's allowing them to browse the web has a reliability of less than 100%. So if you look at the reliability of an upstream DSL provider or your local Wi-Fi or your phone or
so many connections, so many factors.
So many factors, so many ways for them to go wrong. If you were a
pessimistic way, yep.
professional pessimist. So if you look at the effort you have to go to maintain 100% uptime, brackets, and by the way, you never will, close brackets, it turns out that even if you did that, the typical consumer wouldn't see any difference.
To have that kind of wiggle room into realization that, yes, we're going through so many hops, things are going to happen outside of our control, that, you know, no matter how hard we try, things are going to go wrong.
And another reason is that if you do set a target of 100%, the team that you set that target for are necessarily going to be able to do nothing other than react. Because as soon as something goes wrong, their target will have been breached and they must react immediately. So you are condemning those teams to an immediately reactive existence. And it turns out that if you do that, you might think you're doing the right thing because, hey, that team is going to react and that's good because they're going to attack the problem immediately. But actually, it's much better if you don't do that. And if you give them the guaranteed 50% project work time upfront in order to engineer systems that will not go down in that way and have to be reacted to at all in the first place. And that's another key component of the SRE role, which distinguishes it from how other roles, I guess, do engineering operations. We have this hard split precisely because engineering is the magic. Engineering is where we actually get the systems to behave differently and to actually be better in terms of software operability, which is a key thing.
So you mentioned there the SLIs, the indicators, and reporting obviously then is a massive part of this, of being able to produce an SLA and then actually to abide by that and to live by that. So I'm just wondering, how do you decide on what these SLAs and what these SLIs, etc., actually will be, and how do you go about monitoring them?
Yeah, so there's a lot of material here again. I guess one of the things we know, again, I'll locate this in the overall context of kind of user-facing web services, although there are similar arguments that apply in different contexts like transactional or big data or machine learning or so on. But usually in web services, there's some pretty good data showing that if you slow down your web service deliberately, you can watch the users essentially peel away until in the limit, as you have infinite latency, you don't have any users. So you can more or less turn that knob or slider back and forth and watch the users come back on and fall back off. Now, actually, you don't want to do that because there's significant evidence to suggest that if you turn the knob too far to the slow end of things, you lose some of those users and they never come back. Now, that is a factor for something which is, say, a much more like a transactional short post and get a small amount of data back, like a search engine kind of query. For things which are a bit more specialized, like maybe the average user would be a bit more sticky, etc. And it also depends on the business domain that you're in. But basically, it is possible to draw a kind of a 2D graph which shows that as latency goes up and as other negative factors increase, you can watch your user base fall away. And so if you show this graph, to your business leaders and you say, look, here, and typically that number is somewhere between, we'll say, 3 nines and 5 nines. And by that, I mean 99.9% available or 99.99% available. You draw that line somewhere. And when you've drawn that line, you have a rather wonderful thing, which is a thing called an error budget. And an error budget is 1 minus the 99,999 or whatever it is. And that is the amount by which you're allowed to fail. Why is an amount that you're allowed to fail a great thing? It's a fantastic thing because it is an objective way of saying to a dev team or to a business leader or whatever, here is the amount by which we have agreed we can engage in risky behavior.
And we're embracing the fact that failure happens and not trying to just kind of like hide it. And I think that's where, typical DevOps roles, and, we don't want to take the fact that things will break and changes do happen that will cause problems. And it's better to embrace it.
Absolutely. And it also provides a kind of an objective way to talk about failure and unavailability and so on and so forth, which otherwise can get pushed under the carpet.
That's it. And wishy-washy and, that wasn't a real problem and stuff. It's like, if you've hit the error budget, we've got quantitative measurements of actually being able to do this, which as developers we love. These SLAs and stuff, typically you'll see like with big services, or maybe you've had an agreement with like a third party, that you'll get an SLA from them, or maybe Amazon with S3 have got certain SLAs with you, etc. But this SLA is something that you've set to yourself, essentially, isn't it? It's not, it could be public facing, but typically you can have these in internal applications, etc. and whatnot.
Yeah, so they can be applied to a wide variety of things. Obviously, the thing that gets the headlines is kind of the externally facing SLAs, particularly when they're breached, right? So that does tend to get headlines. But actually, for internal services, there's also a business case for them to have it, particularly if they are infrastructure services. There's one interesting tidbit in the first SRE book where we talk a little bit about a service which we call Chubby, which is an internal lock service and a naming service and a bunch of other stuff. But basically, loads of things ended up relying on it. And we said, we're advertising a relatively small SLA for this thing, and yet we're running it so well that it's actually behaving much better. And when we look at all of the services that have ended up using it, none of them really expect it to go away as much as we say it should be allowed to go away. So what we'll do is we'll turn it off until it matches its SLA. And then all of the people who were implicitly relying on it to be performing it more than its SLA will get precisely what they deserve.
That is amazing. That is kind of the, this idea, like the chaos monkey thing of like allowing failure to happen so as to make sure that people, you say, don't implicitly rely on things, and things really happen outside this controlled environment way of doing it. You won't get bit.
Yes, and it's also related to a thing called Hiram's law, Hyrum. Hiram Wright, who was a guy who used to work on the C++ library team in Google, who I spoke a fair bit to. Here's a thing called Hiram's law, which is basically users come to depend on every behavior of your API, no matter what it is.
Absolutely. If it's public, even if it's not documented, it's still available.
Absolutely. And a similar thing kind of applies in the dimension of SLAs as well, which is users come to implicitly depend on the fact that actually you're giving us 4 nines, whereas you only told us you would do 1.5. And that kind of dichotomy between reality and advertisement can be immensely problematic.
So moving this gauge then, obviously it allows you to get this error budget, and we did touch upon it a little bit, but it'd be interesting to maybe, kind of go into more depth about exactly what then is the error budget and what would a dev use this for?
So an error budget is consumed when you do things that create errors. So in the course of, for example, a classic example would be product launches, right? So if you want to do a product launch and you have a fair bit of error budget left, you don't actually have to do all of the standard best practice things that are common in Google. I won't say anything about like where it is or how that works elsewhere, right? But in Google, it's very common for a product launch to be canary launched to some very small part of the population and then gradually increased over time as you make sure that there are no errors as the product is getting more users and registrations and so on and so forth. And you basically have a sliding scale from nothing to 100% of the world, and you check in very regularly. The difficulty with that approach, of course, is that yes, it ensures reliability, but it's very slow. It could well be that you don't get to see the new product for days or possibly weeks, depending on how many errors you discover in the course of your actual rollout. But if you have a lot of error budget, you can just slam the throttle to 100% and let rip. The nice thing about that, of course, that you get more feedback sooner.
And it's very liberating as well, just to be able to do this.
Indeed. The less good thing about it is that you collect, how can I put this, a lot of feedback quite quickly.
Yes.
But that's one classic way. Another way is to perform, well, that's probably the wrong language in that way, but to do kind of A/B style testing on different code paths that you're exposing in your binary. For example, if you want to test that the users are going to navigate their way around this new UI in a particular way, you can A/B test some proportion of your population. And because you've got a lot of error budget, you can do that with 50% of the population rather than the 0.01% you're otherwise going to have it with, and so on.
Nice. And it's interesting because with, so say like obviously in a big company like Google, who monitors and keeps hold of like the error budgets and the SLAs, et cetera, and monitoring those? Is it the SREs that are, who it's related to, or is it an external team?
Oh, yeah. So monitoring is a huge question, of course. And I recall you asked that earlier. So monitoring in Google in particular, in other places also, is done in basically, I'll say, two ways. And the first way is kind of metrics oriented. So a particular binary will export either via push or pull or whatever, a set of metrics, which are typically associated with a counter of some kind. So you'll get something like the requests per second, the requests I have seen in the trailing 60 seconds are X. And then there is a monitoring system which is responsible for taking these metrics, performing aggregations on them typically, because usually in the Google case, there is no particular interest in how one binary is performing. You care how a fleet or a cluster or some aggregation level is performing. And you also care about the aggregated metrics and displays them in some graphical format. That's a fairly common thing in the industry. There's Grafana and there's lots of stuff that does this kind of.
Are these all publicly available to other teams, or is it just to the team and the developers that are related to that?
Yeah, so there's another dimension to metrics or to monitoring as well, which is as well as per team monitoring, there is also a kind of a global monitoring service, which I'll handwave the details on a bit at the moment. But what that basically means is that certainly within Google, there is a well-known path to go to find the metrics for more or less every team that you can guess the name of. So there's a fairly easily guessable name to default monitoring dashboard style mapping. That turns out to be fairly obviously convenient. There is, in the sense of sharing things with the outside world, etc., that doesn't happen so much. The piece of software which resembles Google monitoring the most that has escaped to the outside world is Prometheus, which is written by, as it happens, an ex-Googler and a bunch of other folks. In fact, I think there's a bunch of ex-Googlers working on it. That is quite like the system Borgmon that we wrote about in the first SRE book.
And I suppose making it public, like to other team stuff, is ownership. And it's kind of like, the fact that you can't just hide the fact, the fact that these are numbers that you're giving and these are the metrics currently, and this is the truth. And then you can work around that.
Yeah. And one of the nicest things about Google culture in that way is that it is default open within the company. Obviously, outside the company, it's a kind of a different story, but default open within the company means that a lot of the conversations are about objective data rather than, so tell me what you think happened last night, right? So.
And another, I think you touched upon it a little earlier, but, this idea of, this is another brilliant thing about the SRE role is this 50% cap on operations work, providing that, that the SRE should be doing more development or more, writing code, etc., than they should be tackling fires and, handling stuff reactionary. I'm just wondering, maybe you can expand upon that.
Yeah, so I guess developing from the earlier point, which is that you have to guarantee some time for the project work in order for the engineering to happen, it's actually not expressed all the time in that way. The way that it's sometimes expressed is that it's a cap on operations work rather than a guarantee of project work. And the reason we do that is because a cap on operations work means that it can't get any worse. Whereas a cap on project work would mean it couldn't get any better.
Yeah, it would be very, very negative to do it the other way, wouldn't it?
Yes, indeed. So the cap on operations work is also a useful signal to certainly the ICs on the team and also the management and developer management and so on, that if the SREs find themselves in a position where very regularly they are exceeding that cap, or they have to put down tools in the middle of stuff, etc., because they are exceeding that cap. What that means is that the product is not operable enough. It's not automated enough. It's something that you have to handhold and shepherd round rather than something which will hum over in a corner by itself. Now, of course, there are nuances and a spectrum of possible response here and so on, but it's a useful trigger that when you don't have half of your time to make stuff better and you're just reacting or moving stuff around, the product itself needs some more engineering.
And I think that's where, typically you'll see people who, have done ops in the past where it is essentially this firefighting, which isn't nice. And, you do always feel very negative on it. But how do you monitor the percentage of time? You're saying you've got a 50% cap. How is that actually tracked and kept?
So a lot of it is relatively informal today in the sense that the manager will end up scraping a lot of hand provided statistics by staff folks. And usually when something is particularly bad, it is exceptionally and noticeable that it's exceptional in various dimensions. It's when the folks themselves really begin to feel the pinch of the time in question that kind of triggers the behavior. The reason why it's 50%, there's a bunch of reasons why it would be 50%, but one particular feature about it being 50% is that you can come in the morning, and if you find yourself not having done all of your operational work by after lunch continually, then that is a signal that you have crossed the threshold.
And then also another thing to add on to this is the fact that developers play a role in this as well. And they have about 5% of operations works, which is completed by them. What was the idea behind this and how is this executed?
Yeah, so that goes back and forth. There's a bit of detail there as well. We have in the past and continue to recommend that developers do stay in the on-call rotation for their systems in question because, there's a particular phrase we call the wisdom of production, which is basically a way for production to inform you how your product actually behaves and what your product actually does when it's under stress, which is a very useful signal and can provide you with information, much information about how things actually work as opposed to what your mental model of them was.
Yeah, you're idealistic how it's going to be compared to what the actual truth is.
Yeah, and of course that doesn't just refer to, I thought my product behaved in way X, but it behaves in way X prime, which is obviously useful and that's fine. But also some of those products are infrastructure and other products rely on them as well. And in terms of the stack that's being offered to the rest of the company, if your thing doesn't actually behave as you thought it did, and yet you are going around essentially selling its services to the rest of the company, that is also a useful thing to know.
And it kind of grounds the developers to feel that they have some, it's not throwing it over the wall and just saying like, yeah, operations can deal with that now. I live in my, world where I can just keep happily coding away. And yeah, it provides the real life. This is what's happening. Absolutely.
And the 5% of operations work, which is not on call, which is supposed to be shared as well, also helps to maintain all of that good stuff about parity of esteem and we're all in this together and we're owning the product as well as you and so on and so forth. So there's a lot of value to be gained from that.
I can assume like, maybe a developer seeing, oh, wow, I'm seeing this error again and again and again. They can sympathize with how an SRE to people doing ops actually feels when they actually, see that code.
Yep.
Awesome. And another thing, actually, and this adds on again, to this kind of reactionary, but then blameless postmortems is another really key component. What is a postmortem in this context? And like, how do you go about doing one?
Yeah, so there's a huge amount of work out there in the industry about this. I don't think we obviously wrote about it in the book, but we are by no means pioneers in this. I guess John Allspaw would probably be one of the premier people in the postmortem world. Jessica DeVita as well. I also think of in this context. But basically, postmortem is okay. Something went wrong with the system. What are we going to do about it? And it's an attempt to be an objective record of what happened, and also this thing that at the moment is called RCA, which stands for root cause analysis. You're basically trying to figure out what the root cause was for things going wrong. But the language these days is moving a bit more towards contributory factors, because actually when you look at sufficiently complicated systems, and by the way, almost everything that we run in production today on any kind of stack is sufficiently complicated. What you tend to see is that there are a bunch of factors that contribute towards the failure of a system. And I think, for example, it's not just back-end storage system X failed and therefore system Y was unable to read its configuration and couldn't actually start up when it got restarted after an EPO. Like, it's stuff like, if you remember the famous Hawaii incident where they sent out the message that in fact the missiles were coming and everyone was going to die and so on. It's like having a UI where there's a giant button saying do the wrong thing, and then a tiny 2x2 pixel button saying do the right thing in the bottom of the screen, and when you move your mouse towards it, it moves away from it and so on. Like, there are all kinds of UI factors and human factors and so on that can contribute to a system as a whole going wrong. And it's vitally important when you are analyzing why a system goes wrong, not just to take into account kind of relatively narrow causes and so on. You have to pull in a wider perspective in order to have a serious chance of dropping the chance of failure again. And in order to have a wider perspective, you have to have a blameless approach. Because if you have a blameful approach, which a number of organizations do have, you have active incentives to lie.
And that completely defeats the purpose of a post-mortem and trying to learn from it. Because I'm guessing, is a post-mortem carried out on to any incident that occurs? Or is there kind of a scale of, how much time you'll spend on a post-mortem to how severe the problem was?
There's a lot of nuance there. I think most disciplined SRE teams would say that any incident that crosses the error budget or that causes the error budget to be entirely consumed or more than entirely consumed would say that warrants a postmortem. And sometimes some SRE teams would say, well, that took about a third or half of our error budget, but we're still not entirely happy about the decision process that led to that outcome, so we'd like to investigate it in a bit more detail, etc. The key thing with postmortems is that they have to be done within a reasonable time after the incident itself occurs. Otherwise, you are typically end up going through, maybe not great records. People's memories have faded a bit and so on.
Absolutely. And because also we've mentioned, exhaust the error budget. What happens in that case? What will happen for the developer and also for the SRE?
Yep. So there are a variety of things that can happen when the error budget is exhausted. The default thing is that the next set of changes until the error budget refreshes, and usually there's some kind of agreed upon period at which it refreshes, monthly, quarterly, or whatever, usually not weekly. When the error budget is exhausted, then you stop. You don't stop the service, of course.
Power down. It's not going to be in. It's not sufficient.
We all go home. No.
Yeah. Sorry, guys.
You stop risky change to it. And that means that where you might previously have avoided the canary or staging environment in order to launch your thing, now you do use the canary and staging and launch environment and so on. And you move your time away from implementing business features towards implementing safety features and so on. And sometimes this just applies to the SRE team, and sometimes it applies to the development team as well. There's a fair bit of nuance there because ultimately, in my opinion at least, an SRE team and a developer team, product development team, are most effective when they have a fair degree of flexibility about what they'll do and that they'll take each other seriously. So I've worked on teams before where we had a massive blowout and used like 2.5 years worth of error budget in a single incident, naming no names. And as a result, the developer team said, okay, the fact that this can happen is a fairly serious problem with our product. And so what we will do is we will put chasing product market fit to the side for one moment, in fact, several moments, and we will work on the safety features with you, the SRE team, for a quarter until this thing is done.
And that really is reducing that friction, isn't it? And it's aligning your goals.
Absolutely.
Could you see yourself doing anything but SRE now? Obviously, you've done a lot of operations work in the past, development, DevOps work. It really aligns with kind of the way of thinking. And I'm guessing, you've seen the best results because of using this.
Yeah, again, there's a couple of ways of thinking of it. If you happen to play a board game or board games, you could think of it as keeping a couple of tokens in reserve to spend on like the reliability of your fleet out there in space or whatever. And that could be a very useful hedge. I guess in terms of my own career, today I'm actually Director of Cloud Engineering Services and SRE. So I have a foot in both worlds in the sense of product development in the broadest sense and SRE. But I've been what I'll call a backroom boy or an infrastructure person or however you want to put that. Like I live below the user-facing bit. And I'm very comfortable with that because it means I can get all dirty in the engine and look at how things actually really work behind the scenes.
And how have you seen the role evolve over time? Because as you say, the way Google does it is very different to how another company does it. How has it changed and evolved?
Yeah, there's a couple of different things going on here, I guess. The first one is that there is a practice in the industry. I've been told this face to face, so it's not just me. I have been told this. There's a practice in the industry of people who have found that the book made operations so exciting for them as a thing that they would do that they renamed their operations team SRE and they changed nothing else about them. In my opinion, that is not SRE, right? That mightn't even be SR, but it's certainly SR without the E. It's not a principled reaction to the set of ideas in the book with respect to how to conduct yourself when you're operating services, etc. Now, on the other end of things, there are people who have taken it and they do a very principled error budget, SLA-driven engineering inside companies like the New York Times or so on, like smaller, non-traditional, we'll say, web companies of one kind or another. And so they're taking those ideas and reacting to them and running with them. And some companies do a DevOps model and react to how to do innovative technical stuff within their company in a different way. I think the bit I specifically see changing about SRE is kind of two things. First of all, as it propagates throughout the industry and different people or different organizations do it in kind of a different way, we will hopefully settle on a common definition of the minimal subset of things that you have to be doing in order to be called an SRE. Because one of the things that's very interesting at the moment is what you call yourself versus what you do. So I would really like it if the role achieved a kind of a common definition. And I do see when I go to the various SRE conferences, I do see that the conversation has moved away from questions of identity, more towards questions of, well, what do we actually do on a day-to-day basis and how do we achieve that and so on. And to my mind, the fact that we're gradually moving away from identity means that we are settling on some common notion of what those things are. How the role is changing, it's deeply influenced by cloud. So up to the point that cloud was a big thing, SRE was, I guess, seen as a highly internal, highly inwardly focused activity that wasn't necessarily, that obviously kept stuff up and running and was in some way an advocate for the user in terms of the availability of the thing and performance of it and so on, but wasn't necessarily seen as something that every company, or at least most companies, would need to engage with in some way. But now that SRE and cloud infrastructure are seen to be coupled together, certainly in the minds of many in the cloud industry, that really seems to be something which is pushing it towards mass, if not adoption, then at least engagement.
Absolutely. And one of the things the SRE kind of book and also, the role kind of pertains is this idea of, reacting to issues and practicing that. So, failure is going to happen. So let's be the most performant we can with it. And there's this idea of the concept of the Wheel of Misfortune. In your time at Google, how did you use this and how did you find it benefited?
Yeah, so the underpinning theory there, I guess, is that if you completely outside of the scope of computing in general, if you just look at the general error rates of tasks performed by humans, you see very, very quickly that if a human being is in a stressful situation, then their error rates go up. And it's absolutely unquestionably true. And it's as simple as it ranges from things as simple as misreading the direction that an actual dial is going in, a nuclear power plant or something like that. You will look at it and you will interpret the direction it's going in a different way, through to dropping hammers, through to, like, if you're working with any kind of complicated software as well, particularly one where the UI is do the wrong thing in a massive font and do the right thing in a small font, etc. All of those kinds of approaches lend themselves to error. And one of the ways that you compensate for error is, of course, by drilling yourself to do the right thing multiple times before you have to produce it in the stressful situation. And this is true for, across a huge range of professions. And so the idea behind this Wheel of Misfortune thing, which is essentially D&D for production engineering, right? Which is there's a games master, and the games master comes up with some imaginary scenario which has gone wrong in production. They come up with the scenario, they say it to you, and then you say stuff like, oh, well, I look at the dashboard for X. Is the graph trending down? And then the games master puts a smug smile on their face and says, actually, no, it's not. And you go, oh dear, my first guess isn't right, and so on. But the idea is to replay, in many cases, scenarios that have already happened in production into a kind of a fake environment. With practicing and doing this every week, you get accustomed not only to, I guess, the tools that are to hand to investigate the problem. So you keep hearing the names of tools and approaches and so on and so forth when you're partaking in this. But also you get accustomed to the fact that something suddenly will go badly wrong and you will be responsible for it.
And that obviously means, the value then in the postmortem and how descriptive that is to be able to carry on to do these.
Yep, absolutely.
How do you train someone up to be in the SRE role? I mean, obviously there must be some characteristics that are beneficial to, for someone to do this type of role. And, there's an intrigue. But obviously, different parts of Google, different parts of a company have very different tech stacks and different business domains, etc. How do people train up and move around?
Yeah, so there's a huge amount of detail to this, not all of which I guess would be appropriate for the podcast. In terms of background and training, there are SREs from all kinds of disciplines. I can think of ones from physics, chemistry, statistics, English majors, and a whole bunch of other folks, not just classic computer science and mathematics, although obviously those would predominate. In terms of background, etc., they tend to be folks who are attracted to infrastructure and stuff behind the scenes, fairly obviously, as opposed to UI and UX in general. And in terms of personality traits or whatever, I guess folks who are professional pessimists might have some
problem solvers. Yep.
some kind of bearing on what they do. The exercise of thinking, well, what if this goes wrong at every single possible step, is actually a very interesting mental exercise. And although I wouldn't necessarily recommend it to everyone to conduct on everything.
Oh, so not in your whole life.
For your whole life. It is actually strangely relevant in the domain of computers because what you know, almost everything that can go wrong does go wrong.
Especially at scale of, these companies that you're working for sure.
Indeed.
We've alluded to it, but you contributed to the great book, the SRE book, How Google Runs Production Systems. I'm just interested, what drew you, to contribute to the book, and how did you write? How did you find the writing process?
Yeah, so I guess my own background is I have wrote one book before that book. I have been interested in the topic of education for a long while. I've lectured and stuff like that. So I'm definitely in the frame of mind where I come from a place where sharing and the sharing of knowledge is an inherently good thing. One of the things that initially drove me to instigate this book was a session that I had with other Dublin Google SREs sitting around and saying, there must be a better way to tell people what it is that we do. Because particularly at that stage, I think it was 2012 even or thereabouts, most of the conversations when you're hiring is, hello, would you like to be an SRE? What's that? More or less the second sentence in 99% of recruiting conversations. And after a while, that gets to be a bit of a drag. But also, in terms of sharing knowledge, there's a tremendous amount of practices that were happening inside the company, which obviously had been, in some cases, influenced by things that were outside of the company, and sometimes less so, perhaps. And I felt that it would be doing the industry a good service if we managed to document some of the interesting ideas we had come up with, and would also help to educate the industry about what this job role was, and would also help to, I guess, increase the credibility of what the company was then doing in the cloud space as well. So it kind of served a whole bunch of different functions, but mostly from my point of view, it was about authentically describing our lived experience in a kind of a weird hybrid role, which was fascinating and at the cutting edge of something. Don't quite know if it's life or computer science or whatever, but we were doing things which I felt very strongly should be communicated to the outside world.
Yeah, absolutely. And it is a truly invaluable book. Since its release, how have you found the discussion and understanding of the role then has changed? Have you found that the book has definitely aided the discussion?
It has. At that stage, before I left, Google had kept some metrics about the rates at which incoming candidates would say they understood the role prior to talking to the recruiter and post talking to the recruiter and so on. So there was a noticeable uptick in that. There was a noticeable uptick across publicly accessible domains like Twitter or whatever, sentiment analysis about the role and so on. As far as Google could tell, it made a very significant difference.
And I noticed actually you've recently moved to Microsoft. I think we alluded to that as well. And so your new role, you mentioned the title, what does it encompass for you then? And, what does the future hold for you then?
Yeah, so there's a couple of things going on. I guess in the Microsoft context, I'm attempting to bring some of my hard-won experience, et cetera, to how Microsoft does SRE, because it turns out Microsoft does SRE. And I'm doing that specifically in the context of Azure, which is Microsoft's cloud, as you know. That is a huge, huge opportunity. Obviously, the cloud business as a whole is a huge opportunity. Microsoft as a company with its customer focus and its enterprise leanings and so on, there's just a huge amount of very interesting both technical and organizational engineering work to do there. I'm doing that in Dublin rather than Redmond because I live in Dublin and I live in Ireland, and because I'm essentially starting off the first, as far as I know, large other SRE site that will do the kind of follow the sun support model that I'm so familiar with from Google's institutional capacities.
It sounds very, very exciting.
It is the opportunity of a lifetime, and that's why I'm here.
Absolutely. I say thank you, Noel. Thank you so much for taking the time to come on the show. It's been really interesting, and I'm sure the audience are going to love it, and I definitely did. Discussing all these things.
No worries at all.
Awesome. Well, audience, it's been another great episode, and we'll speak to you again next week. Goodbye.
You've been listening to 3 Devs and a Maybe. You can contact us at contact@3devsandamaybe.com or follow us on Twitter at 3 Devs and a Maybe.